Hi friends, let us explore fork system call in operating systems and gate questions on fork system call.
Let us see what is fork system call. The fork system call is used to create a new process known as a child process by duplicating the calling process, which is also referred as the parent process. First, let us know what is a process. Process is nothing but a program in execution. So, a process in operating system, it means a program in execution. So, when you call a fork function, it will create a child process and it will duplicate the calling process or the parent process.
What will happen if the fork function is executed successfully? It will make two identical copies of address spaces, one for the parent and one for the child. Both processes will start their execution at the next statement following the fork call. As we have discussed, both processes start their execution right after the system call fork. Since every process has its own address space, any modifications will be independent of the others. It means that updation of a variable in child process will not affect the same variable in parent process. Vice versa, updation of a variable in parent process will not affect the same variable in child process. Moreover, the fork does not take any argument, but it returns a process ID. Let us see the header files to be used when we use fork in C programming language. This first header file stdio.h, this is standard input output header file which we use it in all the C programs. This header file unistd.h, because fork is defined in this header file, so we need to include this header file whenever you want to use fork system call. And the third one, the type PID underscore T is defined in this header file sys/types.h, and process IDs are this particular PID underscore T type. Return values when we call the fork system call. In the parent process, the fork returns the process ID of the newly created child process. In the child process, the fork will return 0. When fork returns -1, it means that there is an error in creating the child process, and this error is a built-in variable available in error.h. It is used to indicate the error occurred during the function call in C programming language. Let us see an example program for fork system call. In this C program, we have included header file unistd.h because we are going to use fork system call. So in the main program, so we have used a variable PID which is of integer type, and PID is equal to, I am calling the function fork. So this fork will return value to this variable PID. We have already seen the three possible options for the return values of the fork system call. So as we already discussed, so what will happen to the execution? So you can see this diagram. So this is the parent process. So up to this, this is a parent process. So once you call the fork, what will happen? Right after the fork statement, so this parent process and also there will be a child process, both will start execution after the fork system call. So what will happen now? But you should remember that the parent process will be executed first. So in the parent process, what will be the PID? PID will be the process ID of newly created child process in the parent. So what will happen? That will be the integer data type. So if there is a error, that value will be less than 0. So there is no error means it will check this statement. So we already discussed PID will be 0 in the child process. So but in the parent process, it will have the PID or process ID of newly created process. So what will happen? This statement will be executed in the parent. So you can see the output. So in the parent, it will give the process ID of newly created child process and it will print parent. In the child process also, these statements will be executed. So print up the PID value. So what is the PID in child process? As we already discussed, it is 0. So this statement will not be executed because this condition becomes false. But this will be executed in child process because PID is equal to 0. So it will print child. But this statement will not be executed in child process because here PID is 0. So this is the way the fork system call creates a child process. Let us see another program for fork system call. In this C program, I am going to use the special variable PID underscore T, which is used to store the value of process ID. But in the last program, we have used ordinary integer type variable. But here I am using the special variable PID underscore T. P is equal to, we are calling the fork system call. So as we already discussed, when you call the fork system call, so automatically a child process will be created and both the parent and the child process will start execution right after the fork system call. So here first parent process will be executed. So int x is equal to 3 and what is the p value? P value will have the process ID of newly created child process in the parent. So as far as parent is concerned, this P is not equal to 0. So in case of parent process, this will be executed. That is, in the parent, the value of x is, that is pre-decrement, minus minus x. So that means what will happen? 3 will be subtracted by 1. So in the parent process, it will print 2. So again, in the child process, again the process starts execution right after the fork. So x is equal to 3. But in the child process, we have already seen that the process ID is equal to 0. So this statement will be executed. So in the child, the value of x is pre-increment plus x. That means it will have 4. So you can see the output. So in the case of parent, the value of x is 2. In the child process, the value of x is 4. Let us see a gate question on fork system call. So in this program, we have declared a variable x with the value 3. While loop will execute when the value is, that is x value is greater than 0. And inside the loop, we are calling the fork system call and we are printing the value hello, and wait function is called with the null value and x is decremented by 1. So we have to find the total number of times the printf statement is executed. So this is a gate question. So we will see the answer in the next video, that is gate questions in fork system call part 2.